Hello students, this question is taken from test series 4 EE from the subject electrical missions from the topic DC missions, and it is of linked data question for the question number 52 and 53. In the given question, having 4-pole DC series motor having a flux per pole that is phi is equal to 4 into 10 power minus 3 Ia, which is given flux per pole that is 4 into 10 power minus 3 Ia, where Ia is the armature current. The motor drives a fan, requires 30 Newton meter, which is given. The motor drives a fan that is having the load torque that is 30 Newton meter at 1200 speed RPM. Assuming the motor to be wave connected with 450 conductors and resistance of 1 ohm. So we have to calculate the value of speed of the motor in RPM when fed from 200 volts. So we have to find the value of speed of the motor in RPM. For the speed of the 120 RPM, the load torque required is given as 30 Newton meter. So for speed n RPM, the load torque will be 30 into n by 1200 square, where load torque for fan is equal to the square of the speed. So the motor drives a fan requiring 30 Newton at 1200 RPM. So given for the motor torque, that is Te is equal to 5Zp by 2 pi A into Ia. This is the formula to calculate the motor torque. This is the formula to calculate the motor torque, that is Te is equal to 5Zp by 2 pi A Ia, where phi is given in the problem 4 into 10 power minus 3 Ia, and Z is the conductor is given 450 conductors, and P is the pole, that is 4 pole, 2 pi into A. For wave winding, the value of A is equal to 2. After this is the motor torque. So under steady state conduction, the value of motor torque is equal to the load torque. So we know the value of motor torque, that is Te, and load torque, that is TL. So motor torque is equal to the load torque. After solving this value, we will get the value of armature current, that is Ia is equal to 0.00603 N. So I have calculated the value of armature current, that is Ia. So we know the back EMF, that is EB is equal to Vt minus Ia Ra in motor, that is equal to pi Z Np by 60 into A. This is the formula to calculate the back EMF. So from this we know the value of supply voltage, that is 200, and armature current, that is 0.00603 N, and Ra armature resistance is given in the question 1 ohm, and pi we know Z is conductor, 450 conductors, speed, and P pole 60 into A. For wave winding, the value of wave winding, for wave winding, the value of A is equal to 2. Substitute the value of A is equal to 2 in this formula. After solving this value, we will get the value of 3.6 into 10 power minus 4 n square plus 6 into 10 power minus 3 n minus 200. This is the equation. After solving this equation, we will get the value of speed of the motor in RPM, that is 735.21 RPM. So this is the motor speed in RPM when it is connected to the 200 volts. So option B, which is option B. In this session, we have studied about how to calculate the load torque when given certain condition. For speed of 120 RPM, the load torque should be the 30 Newton meter, and motor torque, and under steady state what are the conditions of the torque, and how to calculate the motor speed in the RPM. Thank you.